to solve another question. Find the one equilibrium index. Equilibrium index of an array is an index such that the sum of elements and lower indices is equal to the sum of elements and higher indices. For example, this array. So the output is 3. That means it's a 0, 1, 2, 3. So this 2 is the output because on left of 2 we have this sum up as -1, and from here to here the sum is also -1. So 3 is what we are looking for. So write a function to that given a sequence of size n, return an equilibrium index if any, or -1 if no equilibrium indices exist. So we only need to find one equilibrium index or -1. We don't need to find all the equilibrium indices. Okay. Now I'm going to draw a diagram to analyze this question. So first we can we look the first element? Yeah, that is a question, because if you have like 3, 2, -2, can you see that 3 is a equilibrium index? Or if you have 3, -3, 2, can you see 2 is the equilibrium index? I'm going to assume yes, because it could be a 0 here because there's nothing here and there's nothing here, so it's just assume it's a 0. So I'm just assuming that we can have the left edge and right edge as equilibrium indices too. Okay, so in that case we should look up all the array, because what we're looking for can be from the start to the end. Okay, so let's analyze this. So when we look at the first index 0, we need to compare 0 with the sum of the rest of the array. If 0 and the sum of the rest is equal, then we can return this index. If not, we should move. So let me mark E here, since this is our first check. If it's not equal, though, we can move the E to the next element and check again. And this time we should add this 0 with this element. So that is the old E, right? And then how can we know the rest sum? So we can calculate the total of this array, and when we subtract the left sum, which is here now, and subtract the current E, we can get the rest of the array sum. Yeah, so for example, if that still doesn't equal, then we move e to the next element, and now the left sum, yeah, we can call it left sum, is here, and the e itself is here, and the right sum, so the rest of the array sum, we call it right sum, and this part is left sum, and that is just array E. So we can compare the left sum with the right sum. If they are equal, then we can return E. If they are not equal, then we should move E to the next element and update the left sum, which is left sum plus the old E, and add the new E here and calculate the right sum accordingly. Yeah, so the pseudocode should be first initialize the left sum as 0, and E as 0 because it's from index 0, and we should calculate total of this array, and then we should be able to find the right sum, which is equal to total minus left sum minus array E. And then we can compare left and right, and if it's equal, then we can return. If not, then we need to first update the left sum because it's going to use the old E. So left sum update, and then update E. And then we should, so again, we should go back to this step to calculate the new right sum, and then compare the new right sum with the new left sum. Okay, now we are ready to write some code. Oh, okay. Let's also think about edge case. So, what if the array has no elements? So, if array equals none, or length of this array equals 0, we should return -1. And if the array has only one element, we can just return index 0. Okay, so now we have an array of 2 or more elements. We should first initialize the left sum. Camel case equals 0 and E equals 0 and total equals sum of the array. And since we have a loop here, so I'm going to write a loop. While I is less than the length of the array. Oh, okay, so it says we already have this length, so I'm going to add it here. So, and right, sum equals total minus left sum minus array E. E stands for equilibrium index here. And compare left and right. If left sum equals right sum, return else we should update left sum. Not nums array E, and we can move E to the next element +1. Okay. Okay. Oh, so we're updating E, not I, so E here. Okay, looking good. And if no return happened, then we return -1, which means no equilibrium indices are found. Okay, so the time complexity of this solution should be O11, because we used a 1 for loop, 1 while loop from start to end, and we also used a sum, which should be also O11, so 2 O11 is still O11, and the space complexity is O1 because we have not used any extra data structure, just some variables. Okay, that's it. Thank you.